All right. So today we're talking about building Windows 8 apps with Windows Azure Mobile Services. My name is Nick Harris. As I mentioned briefly, I'm a technical evangelist for Windows Azure over in Redmond, which is basically the same weather you have here the past couple of days. Nice and rainy. So this is really the first time that we've gone out and talked about mobile services at a public conference. So you guys are really lucky. We only just announced it back a couple weeks ago, really. So I'm not sure if you saw the Scott Goo demo on Channel 9, but there was one there, and that was basically our announcement date on the 28th of last month. So I guess you guys, when you fill out your feedback, you can see whether I did a good first job on this. So the agenda today, we're going to talk about Windows Azure Mobile Services. We're going to look at how you can use Windows Azure Mobile Services for data, push notifications, auth, diagnostics, and scale. And as we go throughout the presentation, we'll sort of build up our knowledge in each of these key areas, and we'll sort of extend a little sample out as we go. So what is Windows Azure Mobile Services? Well, Windows Azure Mobile Services has been created to make it incredibly easy for developers to go and build out a back-end service that a mobile application can consume. So today, our current support is in preview. Our current support, we have a client SDK for Windows Store apps, but we do have future plans to release client SDKs for iOS, Android, and Windows Phone as well. So support for those will come in the near future. But today, we're just Windows Store apps. That being said, if you want to go out and develop against the REST APIs that Mobile Services provides you, you can already get started on those other platforms. In fact, there are a number of people who are already doing that. So the first core component of Windows Azure Mobile Services is data. So we provide the capability for you to have a structured data store for your client application that's up in Windows Azure. We provide the capability for you to easily send push notifications to your Windows Store apps. So that's the scenario whereby you're using the Windows push notification service. You request a channel on the client, you push it up into your mobile service and store it, and then at some later point in time when something interesting that has happened from your application business logic perspective, perhaps the weather forecast has changed or you got a message from someone, you can then push notifications right down to the client application. We provide auth out of the box, so you can basically take those tables that you're exposing through mobile services and turn on that you want that to be secured, whether it's just by application key, whether you want a user to be authenticated through something like Windows Live before being able to sort of consume that data source, or perhaps you may want to restrict it to just admins and scripts, which leads us into the next point. Mobile Services provides what we call server logic, and that's basically a way for you to intercept the CRUD pipeline that's sitting behind your REST services to allow you to run custom scripts that do things that you want for your applications. It may be validation of the data that's being passed up. It may be going and sort of, I guess, manipulating the data that's coming in and storing it out in a few other places. It may be sending a push notification when someone inserts an item. But server logic is a way that we can go and run our own code on the server side in this turnkey mobile service. The next thing that we provide through the portal is the standard diagnostics option, where you can basically just see some of the performance counters that are running on mobile services. We provide the capability for logging, so you can log data with your server-side scripts and then go and see what's happening in those logs. It sort of helps a little bit for debugging your server-side scripts that you're running. And lastly, with all things Windows Azure, we provide scale-out options, and scale up and scale out. Yes? Okay. Background music? Okay. I'll try and yell louder or something. Sorry. So the key scenarios for mobile services, or what they're ideal for, is essentially modern mobile apps, rapid development of your applications. If you consider that you want to go out and build a Windows Store application, you may want to get that out and into industry quick and fast without sort of perhaps sinking a lot of time and effort into building out your own services. So mobile services in this case allows you to spin up those back-end services really fast and get apps built out incredibly simply. The last item there is basically apps requiring structured data. So if you've got any type of application, the classic sample that everyone talks about is, say, to-do lists. But that's basically just showing that, hey, you can store data, insert, update, delete, and read that data back. Obviously, your application scenarios are probably a bit more exciting, but we'll use a to-do list sample today. But essentially, mobile services is targeting those modern apps across multiple platforms, providing developers a rapid development model whereby you don't need to be extremely experienced in building cloud services. You just basically focus on the client application, which adds value to your users. And lastly, structured data, as we discussed. So I think the best way to do this, and the place that I like most, is working with code and doing demos. So what I'll do here is I'll just cut across and we'll do a quick demo. I got a piece of tape here with 3 arrows pointing to the one button, so I think I pressed the right one there. Right. So this is our Windows Azure portal. So who here is familiar with the new Windows Azure portal? A few people. Basically, this is the place that you go and interact with Windows Azure, provision things like storage accounts, databases, websites, virtual machines, and in this case, mobile services. So if we wanted to create our first ever brand new mobile service, it's a matter of coming in. We can see we're on the Mobile Services tab. I can hit New. I click Create. And then the first thing it's asking me for is provide me a unique subdomain that we can use to identify this mobile service. So does anyone have any cool subdomain names we could use here? Yeah. Come on, guys. Aaron Rocks? How's that spelled? Okay, Darren Rocks. Yes, you do. Okay, so database. We're going to choose to use an existing database in the East US. Looks like I've got a little bit of rendering issue there with those images. And we need to provide permission, basically your credential, such that we can go and drop in a new schema into that DB. Hopefully I pasted my password correctly there. So what this is doing now is it's going and essentially spinning up a new mobile service for us. So that's going and allocating a schema to the DB that we're sharing. So you have 10 free mobile services here. All of those 10 free services can point to the one DB. But basically in a few seconds, we've gone and provisioned Darren Rocks. So now that we've got Darren Rocks, we need to do something with it. At the moment, it's just something we can hit, but there's nothing there. So what we provide by default in the getting started sort of dashboard or quick start here in the portal is two options. If you have an existing application and you want to go and integrate mobile services into that app, we've got a step-by-step guide here that you can use to do that. The other option which we've got, which we'll use today, and then we'll extend this application as we move through the deck, is to download a sample application which basically shows you how to perform those basic CRUD operations against your mobile service. So in this case, it's 3 steps. The first to install Visual Studio, done. Install the Mobile Services Client SDK. I've done that. I'll show you where that comes in later. We're going to create a to-do table. So this is creating an actual physical table in our backend that we can go and store data in. You can see my to-do item table there as well. We'll talk about them as we get into some more advanced scenarios. Let me go back to the quick start. And the last thing I'm going to do here, so you can download JavaScript or C# sample applications, but the client SDK actually supports, say, VB.NET, C#, JavaScript, and we've also got a native implementation available as well. Today, are most of you guys C# people? Who's HTML, JS developers? Quite a few here. I'll let you guys stay too. Today, I'm most comfortable with C#, so we'll just use that. So that's one of the cool things about building Windows Store apps is essentially you go out and develop it in whatever language that you're most familiar with. So there we go. I've extracted that. So straight out of the box, we get a solution. Going to spin this guy up. I think I need a bit faster machine, but I'll get there in a second.
You have to, as someone who's
You don't, if you created a Windows Store app that was a HTML5 JS application, you would basically be using Visual Studio to build the app, but all the editing is, it's just HTML and JavaScript files. So really language, as far as what you already understand about HTML and JavaScript, that directly translates into, building your application. You're not sort of throwing away any knowledge there. You will need to learn a little bit about the WinRT APIs, which essentially allow you to interact with, say, the device functionality like the camera or the GPS and those sorts of things. Yes. Yep. Yeah, so you can say new upper class and call a method on it, like the geolocator class, for instance.
So I could do all that in JavaScript without
yes.
going to the API.
Right. You're saying using HTML5, for instance, for that example?
I'm just I don't know what the right question to ask is,
yeah.
but I'm imagining that I could call, just like I call
yep.
a Ruby on Rails or any PHP kind of framework,
yep.
just with naming the method and the class and that kind of thing.
Yeah.
So I'm only needing to stay on the JavaScript level.
Yes.
Is that possible? Or
yeah, no, that's 100% the way it is. Okay. Yeah. So it's designed to be, a familiar experience for you. If you are not a C# developer, HTML.js is like the best option for you. And yeah, it's just call into the APIs as you would with any other API. It's pretty cool. No worries. So I'm just going to spin this app up here, and we'll see sort of out of the box what we get, and then we'll explore the application code a little bit and what it's done in the services for us. So Darren rocks. Yes, he does. So let's hit save. So simple list application. Nick sometimes rocks when demos work. And, the audience rocks. So we can do this. So basic functionality there is performing an insert. We can perform an update to complete something. We can go and query our service for the completed items. So let's have a look at the actual code base here and what that's doing. So the first thing that I mentioned that was one of those downloads was essentially the mobile services client SDK. You can see this pre-provisioned solution goes and drops that in for us. If I wanted to do this in an existing application, I'd just add a reference to it, and you'll find it in your list of references. The next thing for interacting with our mobile services, our mobile service that this application is provisioned, is utilizing the mobile service client class. That comes as part of that client SDK, and you can see that it's already gone and dropped in our domain, Darren Rocks, and this is our application key. So this application key is basically used to ensure that the caller is, someone who should have that application key, but, as with most security things, people can go and exploit these, which is why we provide additional levels where you can go and lock down your services further, which we'll look at a bit further on in this session. So this is the main class we use to interact with our service. If we look at the functionality that we had within our application, we're basically adding to-do items. So we've got a class here that represents that to-do item. It's got some text and a complete field. Within the rest of the code base here, what we do is we essentially get a reference to our to-do item table, and then as we were using the UI to perform inserts and updates and such, the interaction with our service API becomes very simple. It's just one line of code to go and insert that item into your mobile service running in Windows Azure. So for most people who've gone out and built services to do this sort of thing before, you'll find that this is an incredibly simple and extremely fast way to sort of start using a cloud backend. So this is our query. So that was an insert. This is like a read against that table service. So we're performing a read, and we've got some filter criteria here. So we want all items that aren't complete to come back. There's an update again, one line. A delete again would be another line as well. But essentially, incredibly easy to interact with that service. So let's flick back to our service and have a look at what it's done for us. So if we go into this to-do item table, we can see now there's our three columns of data, and you can see that one is true, which I completed, and then the rest are false because they haven't been completed. So that's the basic 101. Let's create a mobile service that's hitting or being consumed by a client application. And I think you'll agree it's quite fast and easy from a code perspective there. So let's return to the deck. And we'll start talking more in depth about each of these things that we've sort of seen and some that we haven't. So when we added that to-do item, it's actually going and being persisted in structured storage. So when I created my mobile service, it provisioned a new schema in an existing database that I have. I could have chosen to target my mobile service to a new database, but hey, I want to be able to have my, say, 10 mobile services all pointing to 1 DB, such that I'm only paying the cost of one database on my subscription. So if you're using a separate or single DB for those different applications, on the slide here, you've got an example of App X and App Y. So they're two different mobile services, and they provide different schemas for that one to-do item table. So that's how they separate the data in the multi-tenant DB sort of fashion. If you want to manage your data, there's a number of ways you can do it. You can do it through the portal, which we just saw. You can use the SQL Silverlight portal that the Windows Azure portal exposes. If you're familiar with SQL Management Studio, you can go and manage your data through that as well. Or you can utilize a REST API, which the client application is using to go and do it as well. But that would be, a bit of extra effort on your behalf. So that was structured data. Yep.
When you say structured data, is that object relational mapping or standard SQL type database structure?
It's a standard SQL DB structure. So consider that mobile services deals with all the dynamic side of that thing as far as the ORM is concerned. And it's just providing you a service API, like a REST API, that you can consume. Everything as far as going and saying, this to-do item has 3 columns and they need to be inserted into the DB, that's done for you automatically. In actual fact, that's what we call dynamic schema. So on the slide here, dynamic schema on-off is basically the capability where you can say, if dynamic schema is on, any entity that's being passed to my service, no matter if it's got 3 properties or 4 properties, mobile service is going to determine the best way to serialize them into your DB, and it'll go and add a column of an appropriate type for that. If you turn mobile service, the dynamic schema off, perhaps after you've finished developing your application and you're releasing it out into the wild, then that dynamic table creation / column adding or removing and such is not done automatically for you. But the server logic, there's a REST API that exposes CRUD operations for you. The server logic portion of this basically allows you to write script that will be intercepted in the CRUD pipeline. So if you're performing an insert, you may want to write some validation code that checks the data that's going in before that insert actually happens. And we'll look at how we can author server-side script here in a second. And again, as you saw in the application, we've got rich querying capability on top of that. As far as server logic is concerned, what modules are supported? So we've got an MS SQL module. There's the MS SQL module there, so that's quite a simple query, but if you wanted to write a query like that, you could. But you don't always have to do this because that API that's provided is essentially an OData head, so you can write your queries directly against that using the client library or directly if you wish to. We support the request module, so you can perform HTTP requests outbound if you want to call into other services. There's a console module for error logging and such. There's a push module for push notifications. We'll demo that today. There's a tables module, which we'll use as well if you want to get a reference to a table and perhaps write your query in JavaScript, provide, say, a where condition that filters data. There's a bunch of status codes there as well, which we'll use as well. So at the moment, we are in preview. So our our data that's coming in on our API and that automatic mapping to columns, it's not extremely rich at the moment, but it's good enough for a large number of applications already. So you can see that if you've got any numeric values coming in and hitting that service, the way we go and choose the data type in SQL is to use, say, a float for that. For Boolean, we're using a bit. Datetime, we're using datetime offset, and string, we're just using an varchar. Eventually, you'll start seeing support for geospatial data types and those sorts of things as we do subsequent releases. So let's have a look at how we can author some server logic and extend this application to perhaps add a little bit of validation. And I think as well, what I'll do is I'll connect to the DB so you guys can see what we're doing there. So let's start at the DB level, actually. So I've got a connection to my database here. Let me refresh it. It's a little bit slow today. And what you can see here on the left is you can see the schema of a few dry runs I did of this session actually. So you can see the schema tens 1, 2, 3 and tens 3, 2, 1, both with those channel and to-do item tables are essentially that petitioning of different mobile services using different schema names. And you can see here we've also got Darren Rocks. If we look at the columns here, you can see we've got the ID text and complete, and they've been automatically created for us when we perform that first insert into the mobile service. So let's go to our portal and look at the server-side script portion. So I'm at the to-do item table. I hit script. And what we can do here now is we can actually author JavaScript to perform some action in that insert pipeline. So the insert won't occur until request.execute is executed. You can see that we've got update, delete, and read operations that you can also go and intercept if you want. I won't I'll discard that for now. But the API is essentially the same. You get an item, which is the item that's being actioned. You get a user, which is the user who's being passed in, and we'll talk about that more in the authentication piece, and the request, which is what does the person want to do. So let's say if the item.text.length is less than 5, then let's say request.respond, and we'll say status codes dot bad request. We'll say too short. Right. And then if it is long enough, then we'll just execute our request. So I can save this now, and this change is going to be up and live. So let's see that in action on my app here. Is it still running there? Let's spin it up again. So let's start with the case that works, so something that's 5 or more. I think that's it. 1, 2, 3, 4, 5. Hit save. So this will work, but if we go back to, say, 4, we'll see that that script is going to be executed, and it's throwing back our exception saying too short. And Wade is tweeting me from over in the corner there. But that's basically our server-side script now intercepting that insert operation and performing some validation for us. And we did that without having to, build this complex solution and deploy it. Essentially, we've just made that change live. Whether you're making changes live or not is sometimes a good and bad thing. There are certainly ways you can avoid doing it to live. You could have a second site that you use for your dev and then copy across your server-side scripts. But server-side script is something that executes in that CRUD operation pipeline that can intercept whatever action we're trying to perform. In this case, we added validation. So we've seen server-side script, and we've also seen our actual DB schema. Let's do one more thing here while we're there. Let's go back to that server-side script, and let's show that dynamic schema functionality. So I'm going to say item.date is equal to new date. I'm going to hit save there. So let me go back to my running application, which is actually it errored out because we hit our validation. So let me just spin that up again. So let's do that, hit save. So there's our testing item, and let's go and see that dynamic schema, go and add that column. So you can see we've now got our date column within our DB, purely just by adding the property to that entity. So that's pretty powerful. And again, if you come back to the portal's basically going to determine and see that that was added, and you can see the date column that's available there with the timestamp in there. So that's our server-side scripts and our structured storage. Let me cut back across here. So next, let's talk about push notifications. Sorry. Yep. Yep. From Management Studio, yes, you can. Yeah. So basically a SQL database in Azure. By default, its firewall rules say only your Azure services can connect to it. But prior to the session, I enabled a firewall rule which gave an IP range for this private network here that allowed me to connect to it. So, yeah. So I can manage that from there. Yep. Yeah. Yep. Yeah. So this is a preview at the moment, and that's certainly something that we've identified as being a problem. If you're just editing and hacking around with code in the server side, you may want to ensure that you're not losing those changes or that history. So we need some kind of source control story where you can perhaps be using TFS or Git or something like that in some deployment story. It's not there yet, but yeah, this is preview. And if you raise that again at the end, I'll take a note of that and send it back as feedback. But I think we better... What's that? At the moment, for your debugging, you're basically limited to the console option, which we'll look at as well. So let's... I think we've got 35 minutes left, and we've got a couple big demos to do still. So let's look at the push notification lifecycle for Windows 8 applications. Essentially, the bits in green down the bottom are things that Microsoft provides for you for free. They're all part of the platform. The things in blue are what we build as application developers. So if I want to send a notification that perhaps lights up my start screen and gives me a nice new live tile or sends a toast notification, there's 3 simple steps you need to go through to be able to do that. The first one is to request a channel URI. So a channel URI is a unique identifier for that application that you can use to post those notifications to that app. The next step that we need to do is we need to take that channel URI and register it with, in this case, our mobile service, such that we can store it in our server side. We may use a channels table or something like that. We store the channel, and then at some point in time, perhaps when an insert occurs, we'll hook into that trigger with the server-side script and send a notification. So when we come to that point where we go, okay, it's now time to send our notification, we grab that channel URI, we authenticate against WNS, and then we push our notification to WNS, which will then deliver our notification payload, a toast or a tile or a badge update, to the notification client platform on your Win8 client, and it will surface that notification to you. So what we'll do now is we'll actually get through this slide, which I forgot I put in there, and then we'll do a demo of that entire workflow. So in mobile services provide the capability to send those toast, tile, and badge notifications. The Windows Azure portal for mobile services will capture your credentials that you need to authenticate against WNS. So a very easy way to provide them there. We've got a module, push.wns.star. The .star is all the different operations, say send toast tile and text 01, toast tile and text 02. So those operations allow you to compose a notification in a few lines of code. We'll build that as well. It's a clean and easy object model such that you don't need to go and deal with or understand how to perform the auth against WNS or how to compose that XML notification payload. It abstracts all that complexity away from you, and it provides a means by which you can do it in a line of code. So let's build that. So I'll cut across, and let's get going here. So the first thing that we sort of need to do in our push scenario is we need to get those credentials. So I've come to manage.dev.live.com whack build, and this is where I can request a set of credentials to use against WNS to send a push notification. So I'm going to put in my package display name and publisher here, so I need to come back to my client app and just grab them. I think it was, so Darren Rocks. And the publisher is just test at the moment, and hit accept. Now what this is doing is it's generating the credential set that we need to be able to send that notification. Did my thing time out here or something? Let me just try that again. Dev. Okay, I'm not sure why that Darren Rocks. Let's drop this guy in. Try again. There they are. Much better. So here are my credentials. The first one needs to go into the client application. So I can drop this into the packaging tab here of the package app-x manifest. The next two credentials need to actually go into my mobile services portal. So if I go to the push option here, you can see that I can drop in my client secret, and I can drop in my package SID. So has anyone built out a notification scenario using Windows Azure and Windows 8 so far today? Right, so how did you find the experience? Was it a lot involved? Oh, you use my code? Okay, cool. Oh, shucks, you make me blush. Yeah, but building it from scratch can be a lot of work. There is some code we built that makes it faster, which the gentlemen there have used, but I think you'll find that the mobile services portal makes it even easier again. So I've pasted in my credentials. The next thing I need to do is I'm going to need to write some client code to request a channel. So I'm going to stop this guy. I'm going to go into my app here, and we're going to start writing some code. So I'm in the onLaunched. So every time the app launches, I want to request a channel. So let's say my var channel is equal to, I think it's await. If I cation, it's a lot harder coding standing up than it is sitting down. So this method here, which is extremely long but very descriptive, creates a channel for your application. And what we can do with that now is we can use our mobile services API here to go and insert that into our mobile service. So that's step one, request a channel. Step two was register the channel. So let's do that. Let's say await, mobile service, get table. Now I'm going to need a channel table here because I want to store all my channels separately. So I've prepared a little snippet. So here's my object or entity I'm going to serialize up there. I've just got an ID and URI. This is a sort of simplified demonstration. So we'll get a handle to the table, and then we're going to insert a new channel, and we'll set that URI equal to the channel URI. Right, close that out. So 2 lines of code, one to request a channel, and the second to register it with my mobile service. So now we've got that done, we actually need to do one thing. So dynamic schematization works for your columns, but we want the developers to define the tables. That means that an admin has actually defined that table, and it's meant to be there. So if I define a channel table here, and we'll come back to the permissions in a bit, but we've got a few permission options there. We'll just say anyone with an application key can perform a CRUD operation. So we'll save that. Okay, so there's our channel table created, and if we click in here, you'll note again, there's only going to be an ID column, and we're going to have the other URI column that was presented in our class created automatically using that dynamic schematization. So the next thing we need to do, now we've got our channel, now we've stored it in a channel table when we run the application, we want to perform some actions. We want to be able to send that notification. So we're going to need to write some server-side scripts. I want a toast notification to be sent every time someone inserts a to-do item. So that's what we'll do here now. So the first thing I want to do, though, is I don't want a one client application registering the same channel multiple times. So I just want to put in a little basic bit of script here that essentially checks to make sure they haven't already registered that channel. So this probably goes back to the gentleman's point about having somewhere to store your code. At the moment, I'm doing it in Notepad. You could do it in the portal here. There is some beginnings of IntelliSense there. It's not excellent today, but it will be in the future. So I'm going to paste this script in here. So let's have a look at some of the things we're using here. I'll just save this first. So this is my channel table. So when I'm performing an insert to my channel, I want to make sure that that channel isn't already registered. So the first thing I'm doing here is getting a reference to the channel table. Now I'm querying, and I'm doing a test, just checking, does the URI that's coming from my client app match a URI that's already in the DB? Those of you who are notification experts, you'll know that that's not a great test because channel URIs do change over time. But for the purpose of this demo, it's okay. I've got a session later on today which goes into more depth on this stuff, if you're interested. But basically, we're saying check if there's a matching channel, and if there is, let's call this insert channel if not found. So this will get our result set back, and we say, does our result set have a length greater than 0? So yes, there was a match. Let's return a response saying that it already exists. Otherwise, let's go ahead and insert it. So now let's go to the good bit where we send our notification. So we're on the to-do item now. We're on the insert operation here. And if I go to my handy scripts, you can come along and we'll walk through this code. And I can drop this guy in. Now this is what's going to send my notification on the insert of a to-do item. So the first thing I do in this script is I basically say execute the request to do the insert and respond to the user immediately. And then once that's done, let's go and send our notification. So to send a notification in this case, I'm basically going to send that to-do item to anyone who's in the channel table. There's more efficient implementations, but this is suitable for demo purposes. But I'm going to say table, get the table for channel, read through the items, or read that table out, iterate through each channel, and then when I find a channel, this is the one magic piece of code here that sends our push notification. So really, that's just a line of code. And in this case, we're sending a toast text 04 with the first line of text matching whatever the to-do item we're inserting has as the description, and just some random data in the other 2 lines. And that's it for our push. On success, I'm logging the response, and on error, I'm logging the response as well. So let's spin up our application now. This would be it here. Push spelt funny. All right. And there's our push notification from Windows Azure Mobile Services. Again, you could use this to send, say, tile notifications. If you want to go and update the start screen, this is a demo we'll be doing later that Josh was having some fun there. We'll come back to that. But that's push notifications in a nutshell from Windows Azure Mobile Services. So the next one we're going to do is we're going to add auth. So with Windows Azure Mobile Services today, you've seen that we're using an application key to perform operations on that service API. But we can also sort of make that, I guess, auth story a bit more granular. We can say, let's ensure that the users are logged in with Windows Live, and then we'll let them perform an action against our table. If you look there at the table level permissions for each CRUD operation, we can basically say everyone can do it, which is anyone can execute any action on that. We can say application key, which is what we use by default. We can say only authenticated users. Today we only support Windows Live. In the future we'll add more identity providers. Or you can say only scripts and admin. If you want more granular control than that again, there's the user object that is passed into every operation in the scripts. And you can use user.level to determine if it's an admin, authenticated, or anonymous user. And you can also use the user ID to get back that unique ID that the identity provider is providing for a particular user. So let's build this. So I'll probably cut across. So for our auth story to work, we actually need to use the Windows Live SDK, and we need to configure it. So I'm going to remain in this portal where we got our WNS credentials. I'm just going to go and edit the settings for Darren Rocks such that we can use the Windows Live API for that. And basically the one thing that we need here is just a redirect domain such that after the user is authenticated, we know where to redirect to. And if we come back to our dashboard, I can get the Darren Rocks URL, just drop that in there and hit save. Now, if you didn't do the push notification portion of the demo that I've done there, you'd also need to copy this client secret, which is the same as you use for push, and you'd need to paste it into the identity tab here, which we do automatically for you if you've done the push scenario, just to make it one step easier. So that's that. Now let's lock down our table. Let's say on our to-do table, we only want inserts to be able to be performed by authenticated users. So if I hit save on that, and you can see you can change it per each operation. Hit save. Let's go back to our Darren Rocks app, and let's try and add something, and we'll see that we'll get an auth error. Boom, unauthorized. So already we've locked down our service for inserts. Now we need to basically provide the capability for a client application to go and authenticate against Windows Live such that they can successfully insert, and then we have an authenticated user. So I'm adding a reference to the Live SDK here, which you can download online from Microsoft. So we've got a reference to the Live SDK. Now the next thing I want to do is basically have a prompt that comes up that authenticates the user via Windows Live and gets back the auth token for that particular user. I'm not sure about the internals for Windows Live. In this particular sample code that I'm doing, I'm actually logging the user out every time. So if I come to the subsequent times without the bit of code, which I'll point out, then I wouldn't have to authenticate again. As for all other apps, I think it depends on whether you have that username and password enabled in the password vault, which sort of can be used by multiple apps. But as far as this single application which we're building now, yes, once you're logged in, it should stay logged in. So when you click on it again, so long as that token's still valid, the user won't have to authenticate.
So it's not maintaining single sign-on at the machine?
For the Windows Live SDK, I'm not too sure about the internals, so I don't actually have an answer to that. I can check that out for you. Does anyone know? Wade? No? Okay. So, yeah, good question. And it's something I can find out. So I've just dropped in some source here. And this is basically the auth piece. So we need to call this. And let's say authenticate. So what we do here in the authenticate is we get a handle to the live client. Again, we need to provide a link to our actual domain for our mobile service. And this is, it's not beautiful code, but we're just saying until the user is logged in with a valid session, let's keep logging in. This is where I was saying force the logout, which just allows you to test with different user accounts. In a real operation, you really wouldn't have that in there. This is just more so if you have two accounts, one perhaps who is an admin for your application versus someone who is just a regular user. It just speeds up your dev cycles. So we call login async, which will show the web authentication broker. And then the last thing that we do is we say, well, if that session is there, let's pass to our mobile service the authentication token. And then all calls through our mobile service as we actually perform an insert or an update is going to drop that in to the header of that request. So let's spin this guy up. Boom, there's our auth. I did make that when I was 13, and I thought it was cool at the time. But the accounts sort of tend to stay with you. So let's, hopefully that password's correct. Yep. So do we want to let this app access my info? Yes. So now we're done. So let's try and do a test insert. And we'll see now that now we can actually successfully call insert, which is before we went and wrote the code to authenticate the user and pass that auth token on to our mobile services client. It was failing. So boom, we've got our insert locked down. And if we wanted all the other operations, be it the update, delete, and such, we could then just come across and change our permissions here again in the same way. And that's basically it for auth. So let's keep going here. So let's talk about diagnostics, logging, and scale. So we do provide some very basic diagnostics at the moment: API calls, CPU time, data out or egress from your mobile service. Provide logging operations, console error, console log, console warn. If you want to scale at the moment, we can scale out the instance count and VM size. If you want to go and sort of scale out your storage, you can actually say, well, rather than having, mobile service number 10 in that same multi-tenant DB, I can actually point that to a brand new DB of its own through the portal. Now that will essentially then have that mobile service with its own dedicated DB, but the one thing that you need to bear in mind there is today we don't migrate the data for that particular tenant as you move it out. You'd have to just write a script to do that yourself at the moment. And you can also scale up your DB size from, anywhere from, I think it's 500 meg up to 150 gig. So let's have a quick look at where they're surfaced in the portal. I'm really not good at this switching business. Here we go. So if I come back to my mobile service, the same familiar experience you have with other dashboards for the other services like VMs or websites or whatnot. You can see that we're logging API calls. So you can see over the duration of the demo, I've performed 13 API calls, consumed 2 seconds of CPU time, and I've pushed out 13 KB of data. The next thing, which is sort of useful to answer the question about debugging, so in my script where I was sending a push notification, I had 2 calls to console.log and console.error. So I'll show you them. So you can see down here my console.log on success and console.error on error. Within the portal, we also surface those logs for you. So you can see that we've got 3 infos here. So I can press details on one, and you can see that this is one of the success calls, and that's a response that's returned by WNS with all this status information when you successfully post a notification to it. So you can see that WNS received the actual message in this case. So as far as logging is concerned, you can log into the portal directly, and it provides an okay place for you to go and sort of figure out if something's going wrong. If we look at scale, you can see at the moment during preview our shared instances. We can't actually increase the instance count on that. In the future, you'll see that capability enabled. We can scale up from a shared core to a reserved core. There is a spending limit warning here saying, hey, this is going to cost some money because mobile services are free for the first 10 until you go to a reserved instance, at which time you have to actually pay for the compute hours. But I've just bumped that up to reserved, and you can see now that I can go and scale that out. So I've already migrated that service over to a reserved instance in a matter of seconds. And hitting save here again, I'm actually now, boom, pushing that across 3 reserved instances, and that again occurs in seconds as well. If I wanted to update my DB size, you can see that I can increase the database size there like that. And I can go to a business edition, which allows you to push up even larger. So that's it for the diagnostics, logging, and scale. If you wanted to change DB, which we talked about, we can specify to go and point this mobile service at a new DB. And we can walk through the wizard here to create that. So now what we've got is a special demo. If he's here. We are all waiting. So Josh is actually sitting in Redmond at the moment, and he is a senior PM on Windows Azure Mobile Services. So it's actually his team that has been doing a whole bunch of work on building mobile services for us to use today. So what Josh is doing now is he's actually built out an application that's way better than the to-do application that we just saw. This one is called do-to. So a very inventive name. Did anyone see a toast pop up here anywhere? There it is. So he's created a list for me that says it's called Nick's Chores. So let me just see if that's going to refresh into here. Yeah, I'm going to have to talk to him about that one. I'm not seeing my list. Let's leave this list. Let me just close that and try and reopen it. There's my liquor list. That was from CloudCover. Oh, there we go. So Nick's Chores, there's my invite. So I can accept my invite into that list. And now we should see that we've got Nick's Chores. So I can clean Josh's shoes, tell all of TechEd New Zealand to follow Josh Twist. And I can add an item here. And basically that's an application that's now using mobile services. He's running this client app all the way over in Redmond on main campus at the moment. I'm here. We're hitting the same service, and you can see that he's got a great sense of humor, and he's actually adding items, and they're refreshing in my application. So now we've got a somewhat interactive experience. So he's going to now change the background for me. So this is an operation which he built into the application, and this allows him to go and change out that background, which we can see on the screen here. So I'll send him a message. We're sort of using a to-do list as an IM client. Okay. So I'll hit refresh here. And we'll see. Okay. Ta-da. So he's changed my background image here. That's funny. Okay. So this is the CloudCover show on Channel 9. Nate and I, Nate over in the front there, we host that every week. Wade behind used to actually run the whole show before he moved on. But there you go. So that's a basic to-do application, and it's all built out using Windows Azure Mobile Services, and you can download this entire sample. If you go to MSDN or your favorite search engine like Bing, you can type in do to Mobile Services sample, and you'll get the full source for this. You can go out and learn how to build these types of apps. The other cool thing that he's done here is he's implemented tile updates, so you can see that all the updates that are going into that list are also being surfaced on my tile here with Josh's Windows Live image. So let me just say, I'll just let him know we're going. All right, and we'll return to our deck because I think we got about 8 minutes left. So what do you think of do to? Okay, better than the regular to do. A bit of user interaction and funny photos. Okay. So that was the do to demo. So let's talk about what you can get for free at Preview. So this is an infographic. I'm sure we're famous for infographics, but this is probably the easiest way I could explain it at the moment. So while we're in Preview, you get 10 free mobile services. Consider it the same as Windows Azure websites. So 10 free mobile services running on shared instances. But these mobile services require a database as the backend for your structured storage, right? So we've seen throughout today's demos that we're adding items and they're going into a DB. Now, at Preview, the DB isn't bundled in those 10 free mobile services, but you can get a free one from the Windows Azure free trial. So essentially, a 1 gigabyte DB from Windows Azure free trial can be used as your backing for these mobile services. If you've got an MSDN subscription and those sorts of things, you've basically got, SQL DB that's going to last you all year while ever you've got that MSDN or BizSpark subscription or whatnot. As far as egress is concerned, 165 meg of daily egress on that via the free trial, and if you've got your Windows Azure subscription through anything else, well then it's based on the egress of that. So again, shared is free. Reserved, so when we scaled up to a reserved mode there, you're basically paying the price for the equivalent VM that you would if you were hosting a VM. And at the moment, VMs are at a 33% discount while they're in Preview as well. But essentially, if you want to get started, you can get started for free. 10 free websites, Windows Azure free trial, boom, you can be up and developing in a couple of minutes, really. SLAs, though, something to keep in mind. During Preview, We have no availability SLA. It is a preview product. We are still developing and pushing out. Obviously, we try to do that in a way that doesn't impact people utilizing it. But if you're building an awesome, huge app on mobile services, or you want to, reach out to me and we can perhaps discuss to see if we can do something to make it a bit better and provide you some form of support for that. At GA, we'll have 99.9% availability. So in summary, we saw mobile services. We had data, notifications, auth, server-side logic and scripts, diagnostics, logging, scale, a client SDK for Windows Store apps, and in the future, we'll have iPhone, Android, and Windows Phone SDKs. Resources, the one-stop shop for anything to do with this is windowsazure.com /mobile. If you want an API reference, I've got a bit.ly there. So on the mobile services developer portal, there's a whole bunch of step-by-step tutorials that you can go out and do. Once you pass the tutorials, you probably want to be looking at the API reference. And as I said, people are already starting to go out and build their own client SDKs because they don't want to wait for Microsoft to do it, and they really want to start developing for, say, iOS and Android and such. So in this case, Chris Reisner, a member of our team, has actually gone off and started building clients for iOS and Android such that he can start using mobile services as a backend for those clients while we wait for the official SDKs. So with that, I think we've got about 4 minutes for Q&A. I've actually got dots here because I'm really interested in what you guys are interested in. Perhaps features that aren't available today in the portal that you'd like to see, such as, you know, a way to be able to edit and author your scripts outside of the portal. So if you have questions for me, I'm happy to take them. Otherwise, if you've got features that you really want in this, let me know, and I'll feed them back to the team, because now's the time to really ask while we're iteratively building this service.
What's the difference between this and Azure websites?
Yep. So websites is basically for hosting a website whereby you write all the code for that. With mobile services, we're providing a turnkey solution where you can stand up that service that's exposing that data store that you want.
So it's basically provides an API for the data store.
Yeah. So mobile services is providing a turnkey API or service that your clients can consume that provides structured storage, the ability to intercept, you know, CRUD operations and execute your own scripts, send push notifications, all at sort of, you know, the few clicks of a button which we had today. If you were building that with Windows Azure Websites, Windows Azure Websites is really cool for the website scenario. This is focused on mobile services. If you wanted to provide the same functionality, you'd have to basically create, say, your web API, you know, write up your API such that it expects, you know, your channel entity. You'd have to write your own persistence tier. You'd have to do all that with websites. So they're two different target scenarios. Yep.
I'm using LightSwitch to create resources.
Yep. LightSwitch for your REST services, you can still publish them to Windows Azure Websites. The scenarios are perhaps somewhat similar, but they're two different, obviously, Microsoft-owned products with different audiences, I'd say, today. Yep. So anything else? Anyone got, like, wish list items? Yes?
Is there anything in the spec that's coming that looks at the client-side caching?
Right.
You've got disconnected devices, say your mobile and your in and out of network service.
Yep. Right. So are you talking for the push notification story, where I'm trying to push data to the client?
Well, it's
Right. I know. You're saying data sync scenario, whereby you can get a copy of the data and pull it back locally to be referenced from that application
you've
when.
got like a salesman
Yeah.
travelling out
Yep.
that might download stuff about the clients he's
Yep.
going to see that's then going
Yep.
back into your masters at some point.
Yep. Data sync certainly a scenario that we'd like to support. How many people here would love to see data sync on this? So that's about 50%. Okay, 60 even. Okay, awesome. Yeah, so we're thinking the right things. We've got 1 minute. I've got to wrap it up, so I can probably take questions after the show here. off to the side if you like. But for those of you that were interested in Windows Azure websites, Nathan Todden up the front there will be presenting the next session here, all about Windows Azure websites. So hang around if you'd like to see that. So thank you.